So as I'm going to dive into this electric field question number 4. So we're given this charge in this region right here. So when we have a charge right there, and we're seeing that we're going to be at a distance that is close and a distance that is far. There is no charge at point A. There is no charge at point B. The only charge is this one single point charge here of this -3 nanocoulombs. So if we wanted to, we could look at this and say, well, this is a negative charge. With a negative charge, we know that the electrical field at point A is going to be pointed towards the charge. We know the electrical field at point B is going to be pointed towards the charge. Not as much as it is at point A, but we know it's going to be pointed to the charge. What do you got? Correct. Yes, it is 0.10 meters. So with this information now, we have the distance. We know the electrical field, the direction of it. Now we're just going to compare the magnitude of it. And the magnitude, that's like a number. But we're not given a number here for either of these electrical fields. So we can compare this through the distance relationship. We do know electric field is force per unit charge. That's what we know as this definition for an electrical field. And in our last week, we went in depth into this Coulomb's law with this force and this inverse square law. So we kind of have this relationship here that this electrical field is going to have an inverse square relationship too with that distance. So it's going to be following that same trend that we had with charge, we're going to have now with electrical field. So when we're at A, this electric field is just going to have a value of whatever it is at A. You couldn't, if you want to, you can set it to a number. I know sometimes it just helps. So I'm going to set it to a number, 9. 9 is a number. I could set it to a random number like 13. I'm just putting it to a number 9. I might come back and change the number, but I'm just going to have it at that number. But really, I'm talking about it arbitrarily as this electric field at that point A. And what we're doing when we go to B is we're going to go from this R of A out to 2 times that R of A. So that R for A is 0.1. We're now going to go out to 0.2, which is 2 times that 0.1. So what happens then with the 1 over R squared, when we double it, we get 1 over now 2R quantity squared. With 1 over 2R squared, we're going to have 1 over 4 and a 1 over R squared. So while this EA has this value of 1 over R squared, we're now going to have E at point B going to be 1/9 or 1/4. So when this EB is going to be this 1/4 of this 1 over R squared. So this EB then is 1 over 4 of this 1 over R squared, which is EA. So we see that the factor is now 1/4. So I could come back and I could say, well, this was an arbitrary number. So sometimes it helps if we call it a number. So I could call it 8. So I could do 1 over 4 times 8. And then I would get a number of 2. I know sometimes that helps when we put in numbers instead of arbitrary units. So if we had an electric field here of 8, then this would have an electric field of 2. And now this electric field is talking about force per unit charge. So we're talking about 2 newtons of force if we put a charge there. Here we would have 8 newtons of force if we had a charge there. That's what this field is saying. So if a charge is here, it would feel 8 newtons of force. If a charge was here, it would feel 2 newtons of force. But really what I wanted us to see was the relationship between this distance to where we get a value over here. We have an electrical field. And then we took R to double that R, and we saw that this electrical field went to 1/4 of that electrical field. So long-winded explanation, but I wanted us to be aware of this inverse square relationship and how it's going to come about and how we can see it. So now that you've answered your EFIL question number 4, I'm going to take us down. We're going to get to this B field. So let's open up B field. Let's click to make a copy of your assignment. All right, so I hope now that you guys are able to open up this B field assignment. And so I have here a video here that is where you can use this to see what I had intended. And if you get lost along the way, you can use this video to help you in this section. But what we're going to do here today is we're going to use an article to make a Google drawing. That's really what we're doing. We're going to use an article to make a Google drawing. So this Google drawing is going to be a model, a picture. It's going to show what a bee would choose, why a bee would choose one flower over another flower. And this is going to be based solely on an electrical field. So we're going to read this article, and we're going to see in this article about what, how a bee chooses a flower to go to based on this electrical field. And so we're going to use this Google drawing here to go ahead and get started. I think it's the same copy as the one I put down here. Yep. So I'm going to make a copy of this B electrical field. So this is the template that we're going to use to get started. And what we got to do is we got to read through an article. And I also have this graphic organizer over here. So I'm also going to open this up as well. I know we're getting a lot of stuff here. I don't normally put this much information on this assignment. So this graphic organizer is something that we're going to be able to use in order to make this Google drawing. So what we have to do is we have to show the sign of the charge on the flowers and the bees. So we have to show that. And we also have to know what charge each of these are going to have. Like, is the bee going to be a positive? Is the bee going to have a negative? Does it have charge at all? The flowers, does it have a positive? Does it have a negative? Does it have a charge at all? And then how are we going to show that charge on these flowers and the bees? And then we're going to show and know, how do we know these electric field lines around these flowers? So we got to try to say something about that. We got to try to have an idea of what we're going to do there. And then how am I going to show where this bee would actually decide based on this electrical field? And you could also show the electrical field strength at 2 locations with units. So if you want to try to do that, that's an optional challenge. If you want to try to get to that, you can. So that's going to be like an organizer, something that I'm going to use to help myself in organizing my thoughts into how I'm making this Google drawing. And I can use this bee field starter as a start. Further, I also have this electric field resource collection. So we went through these where you look through source number 1, source number 2, 3, 4, and I explicitly wanted us to look over these notes. So I want you to have these resources so you can look over this, and this will be something that if you want to refer to this about what an electrical field looks like, how it behaves, and so you have some notes in here saying, well, a positive charge, the electric field goes away from it, a negative charge, the electric field goes towards it. And with more charge, we have more electrical field lines, less charge, we have less electrical field lines. And like showing how it looks when it points from positive to negative. So you have some information here that you can use when you're creating your model to put this all together. When we're done with the Google drawing, we're just going to insert this Google drawing right in here. And the way we do that is you get this, you make a download, you download the file, and we're going to insert an image, check your downloads, and then that gets inserted. But of course, we got to make the model. I just wanted to show us what we got to do and what it looks like when we're done. And we're going to have to also be able to answer this question about how the flowers obtain this electric field and how did the bees sense this electrical field. So we're going to refer to the reading in order to try to really get to this. But once we have those 2 things, then we're done with this assignment, and that's what we're getting checked on. Once again, if you get lost, I have this apply section for this bee field. I have a video for it. I have something here that will help direct us in our thinking as well. So what I want to try to do is I want to try to help us with this article, because I know for me, reading is, well, it's tough. I've always struggled with reading. I don't want to read. I want to just have someone tell me the answer, but that's never how life is. So as I open this up, I have this article. This is what I have for this article, and I can use some of the tools that I have available to me. I can open this up with a Google Doc. And when I open it up with a Google Doc, it creates a Google Doc. And you can have the Google Read and Write read it to you if you want to. If you use your tools, you can use that Google Read and Write, and you can have it read to you. For me, I'm just going to stick with this. And what I'm going to do is I want to try to break it down paragraph by paragraph, because I don't like reading a whole thing. And then afterwards I go, what did I just read? And then I go, I give up. So I'm going to count off a number of paragraphs, and then I'm going to try to create a table on some paper here. So that way I'm going to have on a separate sheet of paper, I'm going to have my paragraph number, and what I think of what it about. And so I'm just going to make 2 columns. So that way, as I read it, I'm going to have an idea, and I can write out something just saying what it about. So that way I have an idea, and I can really use then my notes as some way to make my Google drawing. So I'm going to go back to my article, and let's count off the number of paragraphs that I see. So I see that I have 1 paragraph here, and 2, 3, I'm going to count this as 4. I'm just going to give anytime there's a space, I'm just going to count it as a paragraph. So that's going to be 4. This will be 5, a 6, 7, 8, 9, 10, and 11. So I think it looks like there's 11 paragraphs. So I'm going to even make it so that way I have 11 spots. So I have paragraph number 1, 2, 3, 4. Now, just because I'm making this doesn't mean I have to write something. I don't have to write jack anything, but I do want to have something so that way, well, I don't have to read it 300 times in order to get the information. I want to read it once and get it, and then I'm done reading. So what I'm going to do here is I'm going to read it. And after I read it, I'm not going to read it out loud. I'm going to let you guys read it. And I'm going to go paragraph by paragraph for these 11 paragraphs. I'm going to give us about 30 seconds to read it. And then I'm going to break down and I'm going to write down what I think it's about. So after about 30 seconds, then we're going to come back and I'm going to start talking at you. So I'm going to give us 30 seconds to read this and try to get what this first paragraph is about. So after reading that first paragraph, this is really what I think it's about. I think bees use e-fields. I think that's really what it's talking about. So now I want to try to read paragraph number 2, and I'm going to come back with us and get to what it's about. So after I was reading this, I was seeing that it looks like there's traits for bees to get nectar pretty easy. Like you want to get your nectar, you don't want to have it to where you don't get it. So now let's read up this third paragraph, and I'm going to try to come back. Let's break it down together. So after reading this third paragraph here, what I'm seeing is that the bees, they flap electrons off their wings, leaving it so that way the bee obtains a positive net charge. So this bee is going to have a positive net charge. And then what they were also saying was that they know that this net charge, when the bee lands on the flower, then it's going to affect the flower's charge. But they know that it would affect it temporarily, but they just didn't know that the bees could pick up on it. So the bee picks up on it. So that's what I was reading there. So now let's get to this paragraph number 4. So what I'm seeing with this section is that they measured the bee charge. That's really all I'm seeing there, is that they found some way to measure the bee charge. So as we continue reading here, now let's get to this paragraph number 5. So as I'm reading here in paragraph number 5, really, I'm just seeing that it says that they found that the bee still has a positive charge. So that's what I'm seeing here for this paragraph number 5. Let's get to this paragraph number 6. So as I'm reading this one for paragraph 6, I'm saying that it says that the bee, when they land on the flower, that they were able to measure the electrical potential, and they found that the charge did indeed pass to that flower, and now the flower is positive. So that's what I'm seeing here in this paragraph 6. So we know that the bee obtains a positive charge by flapping the electrons off its wings. The bee has a positive net charge that can then transfer this charge to this flower, giving the flower now a positive net charge. So let's get to this paragraph number 7. Let's see what this is saying. So after reading this paragraph number 7, I was seeing that half the flowers had a positive charge, and that reward, the sweet sugar, and half the flowers had a net charge of 0, and it gave a bitter solution, a bad taste. So the bees over time eventually started going to the sweet solution and this positive charge here. So let's get to now this paragraph number 8. So as I read this paragraph number 8, what I was reading was that with no charge, they go to a random flower. So once they go to this random flower, really what that's saying is that these bees, they have an E-field sensor, and that they're choosing these flowers not based on smell, taste, color, or whatnot. Because when they removed the charge from the flowers, then it went back to random flowers. But when they had the charge on the flowers, they went towards the positive charge flowers. So now let's get to this paragraph number 9. So as I look at this paragraph number 9, what I'm seeing in this paragraph number 9 is that they're saying they're going into their hypothesis, is that they're saying, well, with a positive flower, then that's telling another bee that a bee has been there at that flower. And that maybe then that bee who's going to choose that flower is saying, well, if another bee has been at that flower, then that's a good producing flower. I kind of like to think about this as like back in the old days when restaurants were like with people and stuff. A lot of times people can choose a good restaurant by looking to see where people are. You're not going to go into a restaurant where there's no one else eating. But if there's a lot of people eating at a restaurant, then that might mean that they have good food there. And so maybe that's perhaps what this bee is doing, where if they see a positive flower, then that's telling them that a bee has been at that flower. Therefore, then that's a good producing flower, and they're going to check out, they're going to get to that electrical, they're going to get good nectar by going to a good producing flower. So now let's check out paragraph 10. So as I read paragraph 10, all I'm seeing is that, are there other new senses out there? Like they didn't know that that bees, insects could detect electrical fields. So perhaps if they're able to detect electrical fields, maybe there's something else. Maybe, oh yeah, a restaurant that is packed on a Monday or Tuesday, then that's a good thing. But if they can detect electrical fields, maybe they can detect something else. Maybe there's something that they can see or feel or sense that we don't really even know that they do. So let's check out then this last one. So as I was reading this last one here, kind of just looks like they're looking for other animals, other things, other creatures, insects that really need to get less effort to get a great reward, because a lot of those moths and other bugs, they put in a lot of work just to fly around, just to get a little bit of nectar that is there. So what we're seeing throughout all this is, I'm just going to try to go over my notes. That way I can talk it through and I can get maybe an understanding of what I think this was about. So the first paragraph was saying that bees use electrical fields. The second one, well, they're going to have these traits to get this nectar easily, whether or not it's through sense of smell, taste, or sensing an electrical field. They flap their wings, which removes electrons, leaving it so that way a bee has a positive net charge. And if a bee lands on a flower, then that charge is going to go to that flower, and bees are going to be able to sense it. They measure the bee charge, so a bee definitely does have a positive charge. And they also measure the flowers. And when a bee lands on the flower gets a positive charge. Then they created a separate experiment where they charge the flower and they put in a sweet nectar. And then they had another flower that was not charged, and they put in a bitter taste, and the bee went towards the sweet nectar. But really, it was sensing the electrical field, because they did another experiment where they did no charge. And then the bees went to the flowers with the bad taste and the good taste half the time. So that tells us when there was a charge, they went to a specific flower. When there's no charge, they went random. So that tells us that they are using electrical fields, not smell, not taste, not color, not anything else. They're using electrical fields. And then the logic is well, they're going to go to these positive flowers because a bee has been there and it's producing good nectar, and it's producing stuff that bees will desire. So a bee is going to go there because it's lazier, like all of us. We want to put in the least amount of effort to get the most amount of reward. And so that's what this bee is going to do. He's going to choose this positive flower because he knows that other bees have been there, so it's going to make food for them. Maybe there's other senses. Maybe this can have other animals, other insects. And so that's what this whole article was about. So as I come over here, I'm going to go to my bee field starters. That way I have an idea of what it is that I'm going to do. So how am I going to know the sign of the flowers? So I know the bee is going to have a positive, and a flower can have positive or negative. Oh, so I got some comments here. So if the bees or flowers are always charged, doesn't that mean they're more likely to get? Well, we're talking a small amount of charge. So I got a question here. If bees are getting charged, does that mean they're more likely to get electrocuted? Well, it's kind of like on those dry days, if you ever touch like your little brother or little sister or something like that, and then you feel a little shock, then that's kind of like that. So it's just that static electricity that a lot of us have felt. So yeah, they're more likely to get that kind of charge, that kind of electrocution. And so what we're seeing here is that yes, both the bee and the flower has a positive charge. The flower can have a positive charge or a neutral charge. So yes, if we were talking on solely electrostatic forces, then the positive bee would repel the positive flower. But there's more forces at play here, to where the bee is forcing itself through the air. So it pushes with a greater force on the air than the Coulomb force is going to push on it. And the Coulomb force is also a pretty small force. So what is most likely happening is it's deflecting the hairs on the bee. As it's deflecting the hairs on the bee, just like we have hairs on our arms and legs and whatnot, we can feel slight variations when the wind blows on those. The bee might be able to feel those hairs on its body also rotate or pull in one direction or the other. That would also then lead it to that. So it wouldn't cause a force big enough to move the bee, but it would cause a force big enough to have some kind of sense on it, to have the bee sense the electrical field, not necessarily be pushed around by this electrical field. So we know that the bee has a positive charge. The flower can have a positive or neutral charge. So how am I going to show the amount of charge on the flowers and the bees? Well, I know the positive. I know that the bee will have positive. So B loses 1 electron. Then it has 1 positive as a net charge. And B lands on flower. Then the flower gets, well, technically it would be 1/2 of that net charge, but it would get a net charge, net positive charge. So how am I going to show the electrical field and how do I know the electrical field lines? So we know E field points away from positive. So we got to try to show that. We got to try to show how that E field is going to go around those positive charges. So it's going to point away from positive charges. So we know that kind of stuff. How am I going to show where the bee would decide? So you have to come up with a way So you come up with a way to show this, and how you're going to decide how this bee is going to decide that where to go based on this electrical field. So we already have some information here. So what you got to get then is you got to create this Google drawing. When you create this Google drawing, you're going to insert this into your Google document. So you can create your drawing by adding in some stuff, and then you're going to download. Download it as a PNG or a JPEG. And then you're going to insert this image into your document. So you go to insert image and you upload from your computer, and I get my copy of my bee field. And then we have this here. And with the information we have, we should be able to address this question about how the flowers obtain an electrical field and how the bees sense this electrical field. Once you're done and you're ready to turn this in.